Hello Algebra 2s and happy fall. Can't wait for that cooler weather, right? Certainly still feeling like summer in the classroom. All right, so we're on to day 3, finding zeros algebraically, including multiplicity. Kind of started this and then remembered I had to video for you, so I whited some out. So finding zeros. Zeros are also called roots, x-intercepts, and solutions. That's something you should know from Algebra 1 as well as geometry. It's basically where a function is going to cross the x-axis, okay? So in order to find all the solutions, all of this has to be completely factored. We have already done factoring last unit, so I'm going to jump right to the solutions. So this is x plus 2 and x plus 3. This trinomial would factor to x minus 4 and x plus 1, set equal to 0. Okay? So now we would take each of these factors, set them equal to 0, subtract 2 from both sides, and we get x equals negative 2. I'm not going to do that for each one because by Algebra 2 you should know that if I were to put x plus 3 equal to 0, I'm going to get x equals negative 3. If I were to put x minus 4 set equal to 0 and solve, I would get x equals positive 4. And if I were to put x plus 1 set equal to 0, I would get x equals negative 1. Okay? You've done this in Algebra 1, that the factors are always opposite the roots. Okay? So factors always give opposite roots. Okay? We'll do ones that are a little bit more involved shortly. One thing I do want to tell you is if this were to be multiplied out, x squared times x squared would give me x to the 4th. A 4th degree, whatever the degree of the polynomial is going to equal the number of roots you should get as well. So this would have been a 4th degree. Notice we have 4 roots. Okay? You can also check these in the calculator. I'll show you that on this one. Okay? So exercise 1. First thing we're going to do is we see this is already somewhat factored, but not fully factored. So you're going to need to factor the rest of the way, x plus 3, x minus 3. And this one would be x plus 4, x minus 4. Factors and roots are always opposite. So this is going to give me a negative 3, and this is going to give me a positive 3. So another way we could write that is just positive negative 3. And this is going to give me a negative 4. This is going to give me a positive 4. So I'm just going to write positive negative 4. We notice we have 1, 2, 3, 4 roots. And if I were to multiply this out, again, I would get a 4th root. I mean, a 4th degree. So if it's a 4th degree, I should have 4 roots. Okay? So let me show you real quick the check. Okay? If we are checking this, go to your graphing page, okay, and you would put that function in. I already did, so I'm just going to move up to it. Okay, you already know how to do all of that. Come on, calculator. There we go. Okay, so if I were to go ahead and put this function in the graphing calculator, this is the graph I would get. And you can see the roots are negative 4, negative 3, 3, and 0. But I will write down how we did that. The calculator check, you would put it in f of x and you would graph it. Then you would hit menu. And we're trying to figure out something on the graph, so that means analyze graph. And once we say analyze graph, your choice 1 is 0. So we are trying to find the zeros. Okay, and you'll notice that dotted line comes up. That dotted line is what's going to drag your boundary. So notice it says lower bound. So I don't have 4 over here done, so I'm going to do that for you now. So I would click anywhere to the left of that, and then click anywhere to the right of it. What I mean by left and right is if this is where I want to find the root, I'm going to drag my dotted line to the left of where this crosses, to the right of where it crosses, and then that will show up for you. Okay? So that last step would be to boundarize each root. Okay? All right, so we're going to move on to the next one. The next one is a little bit different. Okay? It's asking a question on, suppose you know that this has 3 real roots. Well, we know it has 3 because that's a cube. And we said whatever the degree is, that should equal the number of roots. However, sometimes we have real roots and sometimes we have imaginary roots. You haven't learned about imaginary yet. That's coming up in a couple of sections or a couple of units, okay? So, if they tell you that this polynomial has a factor of x minus 1, how are we going to find all the rest of the roots? Well, if they're telling you it's a factor, then that means it's divisible. Okay, so you have done that division already. We've tested on that, whether you use long division or the box. Okay, we would divide this out. This problem needs to be divided out. That's going to give me negative 4x squared. Diagonally, this should equal negative 12, so this would have to be negative 8x squared. Divide negative 8x, multiply down as a positive 8x. Diagonally, I need another column. This should equal 3x, so this has got to be a negative 5x. Divide in, that gives me a negative 5, and negative 5 times negative 1 is a positive 5, which checks. So this division is equal to 4x squared minus 8x minus 5. But it's asking me for all the solutions, okay? So far, I only know that 4x cubed minus 12x squared plus 3x plus 5 has a factor of x minus 1, and it has another factor of this, okay? But this I can't get my roots from unless I factor it. So this I still need to factor, and that's factoring by AC. So factoring by AC, again, I'm going to do this quick because this was all last test. If you're not understanding what I'm doing right now, you should be going to Hoops for extra help, or to me after school for extra help, or during a free period, okay? So this would give me the factors of 2x minus 5 and 2x plus 1, and the factor that we already had that they told us. So to see that you divided this or factored it completely in the correct manner, you would do the same thing that we used to do. Put this into f of x, put this into f of x, and make sure that the tables are equivalent, okay? So we've only factored it. These are just factors. It asked you for the solutions, okay? So if it's asking for the solutions, then this we know is the opposite. It gives me x equals 1. This is not just the opposite. We also have to get rid of the 2. So if you need to set it equal to 0, move the 5 over, and divide by 2, you can. Okay? Or you can just, in your head, know that the 1 is going to move to the opposite side, and then I'm going to have to divide it by 2. Okay? So your choice. You could do it either way. But there are my 3 solutions. I have x equals 1, 5 halves, or 2.5. You can write it either way. And negative 1/2 or negative 0.5, you can write it either way. Okay, and then you would check that on the calculator the way I showed you before. 3 solutions, and it's a cube, so we know that that checks. Okay, this next one, I want to just stick to real roots right now. So this one is different than the one that you have. I changed it. Okay, so we're just going to skip that because this involves imaginary and we haven't discussed that yet. So I'm going to jump right to B. Now all of a sudden it's asking for multiplicity. Well, on the previous page, we found 3 different roots for something that was cubed, so each one only counts once, each root. Here, they already have it factored, so I know my root is 4, but if you notice it has a cube, so that means it counts 3 times. So it has a multiplicity of 3. And x equals 2 would have a multiplicity of 8. This is how many times it's going to count. Okay? So if I were to do x to the 3rd times x to the 8th, that's really x to the 11th. The degree is 11. I have a total of 11 roots, even though it looks like I only have 2. Okay? I'll show you that in class as a graph, and you'll see how sometimes it will, as a graph, cut through with a little bit of a wiggle instead of like a line where it just cuts through. Sometimes it'll bounce and so on, but you'll learn that more later, okay? So this one is 2x minus 3 set to 0. Move the 3 over, divide by 2. And because it had a 5th root, that means it has a multiplicity of 5, so it counts 5 times. Okay, this one, 3x plus 4, I would move the 4 over, making it a negative 4, and divide by 3. Okay, I'm just doing the shortcut to that instead of doing this work, so you should be okay with that. Okay, and that would have a multiplicity of 100. You certainly don't want to do that 100 times, right? So this is just like a shortcut. This one would also give me x equals 17 with a multiplicity of 4. Okay? So that means that this degree is really 104th degree. That's a pretty crazy one, right? So kind of working backwards, finding the actual polynomial, if they're giving you this chart, the 0 is 2. That's telling me I have a factor of minus 2 because the 0 or the root is always opposite. But it says a multiplicity of 3. Times, this one is x plus 4 because it's always the opposite. Multiplicity 1, so I don't need to write that. This is x minus 6, multiplicity 6. And the next one is x plus 8. Remember, they're always opposites, and we have that. Okay? So if it's asking you to write a polynomial function, you're just going to write f of x in front of it. And if it wants to know the total degree of it, this would be x to the 3rd times x to the 6th times x to the 10th, or add it up.